Hello friends, how are you all? Welcome to Chemistry Art. Myself Kumar Patel. And today we are going to discuss about the Henry's law. Okay. So in this second chapter, solution, the Henry's law is very important. So we will discuss what is Henry's law. We will discuss the application of the Henry's law. And before it, let me tell you that which we have already discussed in this chapter. So first of all, we have discussed about the definition of the solution. As you can see here, what is solution? It's a homogeneous mixture of two or more substances in a same or different physical state. Okay. Then we have already discussed about the types of the solution. But this type is on the basis of the number of components. How many components are there? Binary solution, ternary solution, quaternary solution. If two are there, it's known as a binary solution. If three are there, it's known as a ternary solution. Four are there, quaternary solution. And the definition about the solute and the solvent. Okay. Now, next, we have already discussed about the types of solution, and it is the first type on the basis of state of solution. Solution can be solid, liquid or gas. As you can see in the table, we have different types of solution: solid, liquid and gas. Depends on the states of the solvent and solute. Okay, we have already discussed about it. Now, the second type, depending upon the amount of solute dissolved in a solvent. And here, unsaturated, saturated and supersaturated solutions are there. Okay, so we have already discussed all the things. Now we are going to start our main topic. So it's a first of all solubility. So what is solubility? What is solubility? The solubility means what? The maximum amount of solute that can be dissolved in a given amount of the solvent. Generally, we are taking as a 100 gram. So at a particular temperature, at a given temperature, is termed as its solubility at that temperature. Because you should know that if we are changing the temperature, the solubility will also be changed. Okay, the solubility will be also changed. So you can't change the temperature. So you have to mention here at a particular temperature, how much amount and maximum amount. Okay, maximum amount of solute that can be dissolved is known as the solubility. Okay, the solubility depends upon the solute in a liquid solvent. So first is the nature of the solute and the solvent. Remember, we are discussing about the solid solute. Okay, solid solute in a liquid. Okay, so nature, as we are knowing that if the polar solute is there, it can be dissolved easily in a polar solvent. But if you are having a non-polar, so non-polar will be dissolved in a non-polar. For example, water is a polar, and if you are dissolving NaCl, so NaCl is also polar. Why? Because Na plus Cl minus. Okay, and in water, as we are knowing that H2O is there, where hydrogen is partially positive and oxygen is partially negative. So polar can be mixed with each other. And non-polar means what? Petrol and kerosene, they are non-polar, so they can mix with each other. Okay, now next, the second factor which is affecting on the solubility. So let's see which is the second factor. So second factor is the temperature of the solution. If temperature will be increased, definitely the solubility will be also increased. But it depends upon the types of that reaction, means how the solution is forming. Is it exothermic reaction or endothermic reaction? This is very important, because exothermic and endothermic, you know that endothermic reaction means what? Delta H of the solution is greater than the 0. It means that endothermic is absorbing the heat energy. So you have to give heat energy. But in case of the exothermic reaction, delta H is less than 0. So increasing temperature can decrease the solubility. So according to the type of solute, solvent and what required, is it exothermic reaction or endothermic reaction, the temperature depends. Okay, so now the third factor which is affecting on the solubility is very important. It's a pressure. Okay, it's a pressure. So in case of solid, the pressure is not having any significant effect. Okay, pressure is not having any significant effect on the solubility, because we are knowing that the solid is not compressible. Solid is not a compressible, and liquid is also not a compressible. We can say that neglect, okay, we can neglect the compressibility of the liquid. So here the pressure is not depend on the, means pressure will not affect the solubility of solid in a liquid. And now we are going to discuss about the solubility of gas solute in a liquid. So here the gas solute, when dissolved in a liquid, some particular factors are affecting, and because we are knowing that the gas is having the compressibility. So very first factor which is affecting the solubility of gas is effect of the pressure, and it is known as a Henry's law. Okay, so what is the statement of Henry's law? See, the most commonly used form of Henry's law states that the partial pressure, see, the partial pressure means P of the gas in a vapor phase is proportional to the mole fraction of the gas in a solution. So let me explain here. For example, I am drawing here. Suppose this is our solvent, and I am dissolving into the carbon dioxide. Okay, CO2 I am dissolving, and here the solution of CO2 is formed. Okay, so what is the pressure? Partial pressure of CO2. P means what? Partial pressure of CO2, and mole fraction, X mole fraction means how much carbon dioxide is dissolved into the solvent. It depends upon the pressure. Okay, so X means what? Mole fraction of the solute, of the gaseous solute. Okay, mole fraction is depend upon the partial pressure of the gas. If the gas is having high pressure, then the solubility will be increased. Okay, more gas can be dissolved. Okay, so here we can say that P is directly proportional with the X. Okay, P is equals to Kh into X, where what is Kh? Kh is the Henry's constant. What is Kh? Kh is the Henry's constant. Okay, and the Kh, the value of the Kh is different for the different solution, and they are different temperature. Okay, so at a particular temperature, the Kh value will be a particular. Okay, so this is the main formula. Okay, P is directly proportional with X, and so you can write, if you are removing proportionality sign, P is equals to Kh into X. Okay, where what is X? It's a mole fraction. Okay, so now let's see the next slide, in which we are going to discuss about the graph of the solubility. Okay, so this is a graph of the solubility, and here you can see that they have taken the solubility on the y-axis and the pressure on the x-axis. Okay, solubility on y-axis and the pressure on the x-axis. So what happens? You can see that different gases are there. Okay, the plots are there for the different gases: oxygen, nitrogen, and helium. And the greater the value of Kh, higher the solubility of the gas. And as we are knowing that what is Kh, so P is equals to Kh into X. Okay, so the solubility will increase with the pressure. Okay, solubility increase with the pressure, and here you can see it on the graph. See, for example, if we are increasing the solubility pressure, suppose here the pressure is 1 bar, then here the pressure is 2 bar. Okay, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar. So let's check. At 1 bar pressure, this is the solubility. At 2 bar pressure, this is the solubility. We are talking about the oxygen. At 3 bar pressure, this is the solubility. So as you can see that the pressure is increasing, the solubility is also increasing. Okay, solubility is also increasing. But these plots are different for the different gases. Okay, so here you can say that the aquatic species are more comfortable in a cold water. More oxygen can be dissolved rather than the warm water. And why it's happening? Because if the temperature is increasing, then the gas solute particle will remove the water surface. For example, okay, here this is water, and these are the oxygen. Okay, these are the oxygen. Okay, so what will happen if temperature will be increased, the gas particles kinetic energy will also increase, and they will leave the surface of the liquid. So the solubility will be decreased, and that's why we can say that in a cold water more oxygen can be dissolved. All the gases. Okay, so now let's see, the next point is the second factor which is affecting the solubility for the gaseous solute. It is temperature. So as you can see here, effect of temperature, as I have discussed with you, that dissolution of the gas is an exothermic process, and it means that it is releasing energy. If you are dissolving some gas into the liquid, it is releasing energy. So according to the law-Satirial principle, with increasing temperature, the solubility of gas in liquid, what will happen? Decreases. Okay, decreases. With increasing temperature, the solubility will be decreasing because of its exothermic process. So exothermic process required less temperature, not more temperature. Okay, so if we are increasing temperature, it means it is opposite of that requirement, and that's why you can say that the more temperature, the less solubility of gaseous compound. Okay, so now next point, nature of the gas. Nature of the gas means what? Which gases are there? Okay, so gases that are mostly liquefied, very easily, are more soluble. Liquefied very easily means what? Which gases can be liquefied very easily? So the gases which are having let me write here, the boiling point. Okay, more boiling point. If the more boiling points are there, it will liquefy very easily. Okay, for example, any gas which is having the 0 degree Celsius, the boiling point is 0 degree Celsius, and another gas, for example, I am giving example X. Okay, X is converting into the liquid because of the boiling point is 0 degree Celsius, and Y, which is converting into the liquid, and the boiling point is minus 50 degree Celsius. Okay, minus 50 degree Celsius. So which gas will convert into liquid first? So X will convert it to the liquid first. It means that if you are having the gas which is having high boiling point, it will dissolve in a liquid very fast. Okay, so gases more easily liquefied are more soluble, and examples are there. For example, SO2, CO2, these gases are easily dissolved into the liquid, but oxygen, nitrogen, hydrogen, they cannot be easily dissolved because of their boiling points are very less in minus. Oxygen approximately minus 183 is there, nitrogen 186 something is there. It means that they are in minus. Okay, so the first point was factor affecting on the solubility, it was the pressure. The second point, effect of temperature. The third point, nature of the gas, and the fourth point is nature of the solvent. It is very important because which kind of solvent is there and which kind of solute is there. Okay, so we can say if you are having a polar solvent, so ionic compound can be dissolved very easily. So gases which can ionized in aqueous solution, okay, gases which can ionize in aqueous solution are more soluble in water, because water is itself polar solvent, as you are knowing that. Okay, as compared to the other solvent, the ionic compound or ionized gases, the gas which can be ionized, okay, ionized gas means what? The gas can convert into positive negative ion. They can be more soluble in water. For example, carbon dioxide. Okay, if carbon dioxide is dissolving CO2, it is forming CO2 plus H2O, it is forming H2CO3. It's a carbonic acid, H2CO3, in which H plus is there and CO3 minus is there. Okay, so they are forming, they are converting into the ions. Okay, so they can be very easily. So nature of solvent is also depend. Okay, now we have discussed about the Henry's law. Okay, and it is the pressure is directly proportional with the mole fraction. So now let's see where Henry's law can be used. Henry's law is obeying only when the pressure is not too high, second, the temperature is not too low, then the gas molecules do not associated or dissociated in the solvent, and the gas is not highly soluble in the solvent. Means what? Pressure is not too high, so the gas compound should not be at high pressure. Okay, temperature will also you have to take not too much low, not too much low. Gas molecules do not dissociate or associate. Dissociated means what? They should not convert from one molecule to two or three molecule. Okay, means dissociation should not be there. And association means what? They should not coagulate. Okay, different molecule combining, this should not be happen. Okay, so for that gases we can only apply the Henry's law, and Henry's law is the not highly soluble in a solvent. Okay, the gas which is not highly soluble in a solvent, we can apply Henry's law for these gases only. Okay, now last point is the gas does not chemically react. It is also very important. Okay, gas should not chemically react with the solvent. That kind of gas we can apply them only the Henry's law. Okay, now application of Henry's law, let's fast finish it. In a manufacture of the soft drink and soda water, carbon dioxide is passed at a high pressure to increase its solubility. Okay, so see here, carbon dioxide is present, and as you are opening the cap of the bottle of this cold drink, you can see the bubbles. Okay, you can see the bubbles of carbon dioxide. Why? Because when the bottle was closed, the cap was closed, the carbon dioxide cannot come out. But here now when the cap is open, the CO2 can be easily come out because the pressure is released now. Okay, so now let's see second application for the Henry's law. It's to minimize the painful effect bands accompanying the decompression of deep sea divers. Scuba divers are using the cylinder of oxygen. Okay, so O2 diluted with the less soluble, and gas is used as a breathing gas. Okay, so you can see that the oxygen is used. And the third, very important, at the high altitude the partial pressure of oxygen is less than that ground level. So this leads to the low concentration of oxygen into the blood of the climber, which acquires the anoxia. Okay, your brain will not get enough blood. Okay, because at high altitude the partial pressure of oxygen is very less. Okay, the air is very thin, partial pressure is less. So according to Henry's law, we can say that if the partial pressure is more than, and then enough amount of oxygen can be dissolved in our blood, and that's why we required oxygen cylinder. Okay, so these are the applications of Henry's law. I hope you understood very well, and if any doubt is there, please let me know in a comment. Thank you very much for watching this video. Bye.